Okay, this revision worksheet is to prepare you for your WA1. A lot of these topics were not taught by me. Okay, so I will try to go through each of these as a topic, like teaching again how to do all these questions. So if you look at question 1, written as a product of its prime factors, 1584 can be written as 2 to the power of something times 3 to the power of something times 11. They are actually asking you to do a prime factorization on 1584. Okay, factorization means I write the same number but in terms of something times something. So for example, it can be as simple as writing 6 as 2 times 3 is a factorization. Instead of 6, I write it as 2 times 3. 2 and 3 are the factors. Okay, so how do we break down a number into its prime factors? We need to know what are prime factors. Prime factors are the building block. When I want to times thing, they are the smallest already. Meaning it cannot be broken down into smaller building blocks already. So my smallest prime number is first a 2. Okay, the first prime number is 2 and it is the only even number because subsequently any even number can be divided by 2. So when I want to know the first few prime numbers, I can go like that, 2, then the next one is 3. Okay, 3 can only divide by itself and 1, so it's a prime number. Then the next number is 4, but 4 is an even number, can divide by 2, so 4 is not a prime number. Then we go to 5, then 6 is even number, cannot. Then 7, 8 is even, cannot. Then we go to 9, but 9 can be divided by 3, so other than itself it still can divide by 3, so 9 also cannot. Then 10 even number, cannot. Then the next one 11, next one 12 is even number, cannot. Then 13, 14 even number, cannot. 15 can divide by 3, can divide by 5 also, so 15 also cannot. 16 even number, cannot, so the next one 17. Then 18 cannot, even number. Then 19 cannot divide by anything else, so can. 20 even number. 21 can divide by 3, so cannot. 22 even number, so the next one 23. Usually you won't be required to go until so far, so you have the front few, probably until 17 is enough, or even 19. Even 19 also seldom already. Okay, then when we are doing prime factorization, we keep testing whether the number can divide by prime numbers or not, and then we always go from small to big. So if we start with 1584, there are 2 ways to present your answer. Then I think students usually like to do by ladder. Okay, so 1584, I try with the first smallest prime number, which is 2. So on my calculator, I just take my calculator and then I key in 1584, then I press divide by 2, then I see whether it can be a whole number or not. So 1584, I go and press divide by 2, I get 792, means it is divisible by 2. Okay, then it can divide by 2, I put 2 here. Then after divide by 2, I have 792. Then I try again, I continue with my calculator. Now my calculator shows 792, I divide by 2 again. Then 396, so still can divide by 2. So I continue. Then I press divide by 2 again. Still whole number, so I continue. If I can divide by 2, I keep dividing by 2. Then I press divide by 2 again, I get 99. Okay, 99 is an odd number, so cannot divide by 2 already. If I don't know, then I continue to press divide by 2. Then I get a fraction or I get a decimal, then I know cannot. Okay, then I go back to 99. Then after I finish 2 already, I will try the next number, 3. So I press my calculator, divide by 3. whole number, can. 3 can, then I still continue to try 3. Then 11, okay, I can stop here if I know 11 is a prime number. I know 11 is a prime number. But if I don't know, then I will press divide by 3 again. Then it's not a whole number. Then I go back to 11, go and press divide by 5. Also cannot. Divide by 7, also cannot. Then 11 is a prime number. So I can stop there. So all these things on the left, 2, 2, 2, 2, 4, 3, 3, and the last one 11, they multiply together, they will give you back your 1584. So in other words, my 1584, I write here, can be written as 2 multiplied by itself 4 times. So 2 to the power of 4. Then multiply 3 2 times. So 3 to the power of 2. Then multiply 11. So this is prime factorization. So once I prime factorization already, I compare to what they give me, then I know, by comparing the power of 2 is x, the power of 2 is 4. So from there, I can know x is equals to 4. Then I compare the power of the 3. Then I can know y equals to 2. Okay? Okay. The ladder one is what I think most students do. For myself, actually, I prefer to use the look like pyramid or look like a tree one. Actually, they are doing the same thing. What is important is you divide by 2, then what number you get. Then the 2 leave there, then your 792 you try, whether can still divide by 2, then it becomes 396. Whether still can divide by 2, 198. Still can divide by 2, 99. Then now 2 cannot already, 3 you will get 33, divide by 3 get 11. Then it is the same. The idea is the same. Always start with the smallest prime number, try until cannot, try the next one, try until cannot, try the next one, try the next one. Okay? So that is prime factorization. Then question 2 is still on all these prime factors, but they want you to find the HCF. Okay, so to find HCF means highest common factor. Okay, so highest common factor, the highest is a misleading thing. What is important is the word factor. Okay, comparing highest common factor and later question 3, lowest common multiple. So the most important word is actually the factor or the multiple. Okay, so let us take a look first. What are factors and multiples? If I use the same example, 6 can be written as 2 times 3. 2 and 3 are the factors. So 2 and 3 are numbers smaller than 6. So factors is actually something that is smaller one. Okay, compared to multiples. What are the multiples of 6? Multiples of 6 can be 6. 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. So all these are multiples. So multiples are bigger number. Factors are smaller number. Okay, factors are smaller, multiples are bigger. Then let us look at how we solve HCF if we already have the prime factorized form. So let us go back to question 2. They tell us P is 2 cubed times 3 square times 5. Then they tell me Q also. Then I write down my Q in the next line. Okay, then Q is 3 to the power of 5, 5 square and 11. So Q don't have a 2. I will leave this blank over here so that it's easier for me to compare. So this 3 power 5 I write in line with the 3 square from P. Then my 5 square I write in line with the 5. Then I still have a times 11 that P don't have. Okay, once I write them like that, one line above the other, I can straight away write the HCF, because I can find the HCF just by comparing their prime factors. Then how do I pick the numbers? I am finding HCF, so the keyword is factor. Factor is something small. To get something small, I must be very choosy. Okay, so between P and Q, power 2, the base 2, 2 to the power of 3, then the other one don't even have a 2. So I have to be very choosy because I want to choose smaller things. Factors, I want to choose smaller things. So between 2 cube and don't have, I choose don't have, the smaller one. Okay, then between 3 square and 3 to the power of 5, I choose the smaller one because of factor. So I choose 3 square. Between 5 and 5 square, I choose 5. Between don't have 11 and 11, I choose don't have. So the highest common factor is this 3 square times 5. Okay, then in question 2, the question say find in index notation the highest common factor. So my highest common factor is now 3 square times 5 lor. This is index notation, or this factorized form is called the index notation already. Okay, then question 3, we compare to question 3. Question 3 asks us to find LCM. So same one, I write down the numbers that I'm given, one row above the other. The second row is 2 cube times 3 square times 5 times 7. This time I want to find LCM. The keyword is M. M is multiple. Multiple is something that is bigger. Okay, so if I want bigger things, multiples, again I go and choose between 2 cube and 2 cube, both the same lah. So I choose the bigger one of them, so it's 2 cube. Between 3 and 3 square, I will choose 3 square because 3 square is bigger than just 3. Between 5 square and 5, choose 5 square. Between don't have 7 and have 7, I choose 7 because multiples, I want big things. Okay, then this time question 3, they say find the LCM. They never say leave in index notation, so I have to key all this into the calculator, then let the calculator tell me this string of number will result in what value, what is one number. Okay, so I go and press 2 cube times 3 square times 5 square times 7, I will have 12600. So I must write the answer as 12600 for question 3 because they never say leave in index notation. So they just want this number 12600. Okay. Okay, question 4 is on ratio. Ash, Barney and Caleb have some sweets. Ratio of Ash to Barney, okay, is 1:3. So A Ash is to Barney is 1:3. Okay, then they also tell me Barney to Caleb is 5:2. Now the next line, if Ash had 5 sweets, so Ash have 5 sweets, calculate the number of sweets that Barney have. Now this ratio is in the simplest form, 1:3. So I can also see this as Ash has 1 unit, Barney has 3 units. Okay, so Ash 1 unit, then they also tell you Ash is 5 sweets. So every 1 unit is 5 sweets. 1 unit 5 sweets. If I want to find out Barney have how many, Barney has 3 units. So 1 to 3 is multiply 3. Then if I want how many sweets he have, I also multiply 3 lor. 1 unit is 5, 3 units is 3 times 5, so 15 sweets. This part quite simple. Okay, then part B. At first they tell me Ashton to Barney is 1:3. Then they also tell me Barney to Caleb, B to C, B Barney Caleb is 5:2. Okay, so if I add another C over here, then I write new line already because they don't belong to the same line. So Barney to Caleb, I write another new line, 5:2. Then now what they want now is ratio of A to B to C. Meaning, at first I have two lines. One line is A and B. The other line is B and C. They want me to combine these two lines into one line. And to make that happen, I must go and find which one is common. A only first line have, second line don't have. C only second line have, first line don't have. So it's not common. What is common is B. First line have a 3, second line have a 5. Then to make them combine into one line, I need to find the lowest common multiple for the two lines. So 3 and 5, I want to make them a same number by multiplying or dividing. Okay, so it's like finding the common denominator like that. It's the same idea. So to find common denominator between 3 and 5, 3 times 5 lor. Okay, then 5 times 3 lor. Then if I want 3 times 5, when I multiply 5 to the first line, I multiply B by 3, I also need to multiply A by 3. Okay, I can only make them same by using multiplication and division. Cannot be plus and minus. Okay, then 5 I need to multiply 3. So same, second line, I multiply 5 by 3, I need to multiply 2 by 3 also. Then the middle, now B, whether it's first line or second line, after multiply already, 3 times 5 is 15. 3 times 5 is 15, so it will become 15. Then my A, I need to multiply 5 So after I multiply 5, it will become 5 is to 15. 1 is to 3 is the same as 5 is to 15. So I am writing the same ratio, just that it is now written the B differently. So the same idea, B and C, I have changed 5 multiply 3 to become 15. So my 2 must multiply 3 also to become 6. Then I will be able to combine the two lines of ratio into one line of 3 ratios. Because 5 is to 2 is also the same as 15 is to 6. Then now 15 is common already, I can put them all in the same line. Okay? Okay, question 5. Okay, when I'm looking at question 5, there is a string of number and alphabet. But when I look at all these things, I must be clear what is happening. Actually, what is happening is 5x means 5 times of x. So 5 times x already, I need to minus 2 times of y. Then after that, I need to minus, when I don't have anything between the number and the bracket, it is actually 3 times of the bracket. Then inside the bracket, got x minus 3y. 3y is also 3 times y. That is what this thing whole line is saying. Okay, so 5x, 2y, this one, and the 3y inside the bracket is quite straightforward. So we can see it as there is a 5x minus a 2y, then minus a 3 times of this bracket. This is the actual thing that is happening. So if I were to work this, primary school you also know, multiplication comes before plus or minus. Okay, so as a start, I cannot do anything to 5x minus 2y. They are different things. One is x, one is y. I also cannot simplify them. So I cannot do anything to them. What I need to do first is the multiplication. 3 times of the bracket. 3 times of the bracket means everything inside the bracket. Inside the bracket got 2 things. Got x, got minus 3y. Everything inside I also must multiply 3. And then after I multiply already, I subtract them. The multiplication comes before the subtract. Okay, so 3 times of x is 3x. Then I am minusing 3x. So I will have minus 3x. Then the multiplication comes first. So 3 times of negative 3y is negative 9y. So when I have negative 9y already, then I am actually minusing negative 9y. minus negative 9y, that's why change to plus 9y. Okay? Or, just like your normal rainbow method, we can include this minus with your 3. Then when you are multiplying, it will be a bit faster. Negative 3 times positive x, negative, positive, negative. Negative 3 times negative 3y, negative, negative, positive. Then 3 times 3y, 9y. Okay? So this is the main idea about expansion. Okay, then we group all the x terms together, all the y terms together. 5x and minus 3x, sorry. So I'll have 2x. Minus 2y plus 9y. So plus 7y. Answer. Okay. Okay, question 6. Question 5 is also algebra. Question 6 is also algebra, but they are very different. Number 1, this one is simplify. So there is no change to this line. I just make this original line look simpler. I am not changing it in any way. So my answer 2x plus 7y is actually same as what they give me. They are the same. Just look simpler. Simplify. Okay. Then question 6 is very different. They say solve the equation. Okay. When they say solve the equation, this equation, the unknown is p. Means when they say solve the equation, what the question is really saying is, they are asking you, what is p? Okay? So when people ask you to solve, they are asking you what is p. Then you must answer, p is something. What is p? P is what? The number. What is this number that p should be? P is something. Or in mathematics, we write it in a bit of short form. P equals to something. So P equals to something will be your answer. Definitely one. When you're asked to solve equation, the unknown is what you want to find. So in this case, the unknown is P. Then my answer is P equals to, and put all the numbers here. Okay? Then that one requires me to move the terms around. Okay? So my 3P is already on the left. Then finally, I want all the P together at one place on the left. All the number to go to the right. So my 3P is on the left. I keep my 3P on the left. I have a minus P on the right hand side of the equation. But I don't want any P to be on the right hand side. In the end, all my P should be together. So this minus P, I want it to disappear. I need to add a P. Minus P, add a P will become 0. But I want to add P to the right. I am writing equation. I want to write the next equation from the first equation. The first equation they give me is a clue. Okay? And left 3P minus 11 is the same as 9 minus P. If I want to write the next equation, I can do anything to the left, I can do anything to the right, as long as I do the same thing to both sides. Then left and right can still be equal. Okay? I can add 1 to both sides, they will still be the same. Left hand side and right hand side. I can add 1000 to the left and add 1000 to the right, they will still remain the same. I can subtract, as long as I subtract both same side, the same thing, they will still be the same. So now what I want to add is P. I want to add P to both sides. Because when I add P to the right side, P minus P plus a P, it will cancel away. I will no longer have a P on the right. Okay? So I want to add P to the right, then I have to add P to the left at the same time. Or you can see it as this minus P cross the equal sign to the other side, and then minus will become plus. Okay, but actually it's because I add P to both sides. Then this 9 on the right, I never touch it, so it's still on the right. But I want the minus 11 to disappear from the left. Left, I only want my P terms. So I want negative 11 to go to the right, it will become plus 11. Okay, same idea. I plus 11 to the left, it will disappear. Then I plus 11 to the right at the same time. So the equation is still balanced. Left still equals to the right. Then when I manage to write this equation, I can simplify. 3p plus p is 4p. 9 plus 11 is 20. Left hand side still the same as right hand side. Then finally I want p. I don't want 4p if I only look at the left. From 4p I want to become p, I need to divide by 4. Then when I divide the left hand side by 4, my 4p will become p. Then I want to divide left hand side by 4, my right hand side also must divide by 4. Okay? Or another way to look at it is this left hand side is 4 times p. So my 4 cross the equal sign, multiply 4 become divide by 4. From numerator it go to denominator. Then I can get my p equals to 5. Okay. Okay, question 7 is on your identity. So you are asked to expand and simplify the following. There are 3 special identities that you all come across before. The first one is if you have 2 numbers added together and you square them, it will expand and simplify into the front is square, the back is square, plus also, and then you have 2 times of the front times the back. Okay, then if you have front minus back being square, it can expand and be simplified to the front is being squared, the back is being squared, and then you have a minus 2 times the front times the back. Then the third one, if you have front plus back bracketed multiply front minus back bracketed, it can simplify into just front square minus back square. Okay, this third one is usually used in reverse. They give you something square minus something square, then you will require to factorize. Difference in the squares, you can use this special identity. Okay, then if we were to apply this special identity to these questions, for part A, when I look at it, 2b minus 9 whole thing is being square, so there is something at the front. The front is 2b. There is something at the back, 9. So this one actually looks like this one, front minus back. Okay, so I can straight away use my identity if I remember. Then I will think, oh, the front is being squared. The front is 2b, so I must put 2b inside a bracket, and then I go and square it. The front is being squared. Then the back is 9. Then I have a plus 9 is being squared. Then this is minus, in the middle is minus, so I have 2 minus 2 times of the front and the back. If I use the identity, I can come to my answer faster. The whole of 2b is being squared, so my square must give to 2. 2 square become 4. b square become b square. Then expand 2 times 2, 4. 4 times 9, 36. Then 9 square, 81. Answer. Okay, if I don't remember the identity, I can also go and work it out. I can go and work out the bracket is being squared, so the bracket itself, 2b minus 9, the whole bracket is multiplied by itself. I can go and slowly expand. It will come back to this short one. So if I know the identity, I can get to it faster. Okay, and for part B, something minus something, something plus something, front plus back, multiply front minus back. So this one, this time it is actually similar to this one, front plus back, front minus back. Okay, so if I apply, I will be left with the front being squared. The front is 2x, so 2x being squared minus the back being squared. The back is 14 squared. So I will have 4x squared minus 196. Answer. Okay, last one. front plus back, whole thing being squared. So use the identity. This is the third one. So I will have the front is being squared plus the back is being squared plus 2 times the front times the back. Back is 50. Simplify, k square plus 30k plus 225. Answer. Okay, question 8. This one, the expansion is not the difficult part, but there is something that is very important here. Okay, when we see this string of algebra thing, again we must we know what is happening. So this is actually a bracket, multiply this bracket, then after that I want to subtract this whole thing here. This whole thing here is this bracket being squared. Okay, so I am subtracting this entire thing. So you must be very careful. So this front, you can go and do your own expansion, but there is also another way to make it a bit simpler. Y plus 4x is also 4x plus y. Then I will have front minus back, front plus back. So that one is actually quite easy to do the expansion already if you remember the identity. Front plus back, front minus back. So it will be end up front square minus back square. Okay, what is important here is this one. Even if you remember the identity, you don't remember the identity, normally what you will do, let's say I straight away apply the identity, then I will have the front being squared plus the back being squared plus 2 times the front times the back. Okay, if I write like that, I minus, then I expand this like that, wrong already. Okay, why? Because I am subtracting. I should be minusing everything here. So now everything here becomes this everything here. If I only put minus in front, then I am only minusing this first bracket. I minus this thing already. I never minus this second string of thing. These things here. I never minus this. I never minus this. Okay, so to remind myself that I need to minus everything here, I need to put everything here inside a bracket first, so that I am minusing everything here, even after I do the expansion. So this bracket here, I put in red, is very important. You are subtracting everything inside. Okay, then we go and do our simplify and expansion. 4 square 16 x squared minus y squared. Okay, I can slowly go and do the simplification one, no hurry, just that I need to have these brackets here. Then front square, 3x being square will have 9x squared. Then 2 times 3, 6, 6 times 2, 12, 12xy. 2 square 4 y square. Okay, so after the expansion, my initial 3x plus 2y whole thing square become these three things. So when I'm subtracting, I need to subtract everything here. Okay, so simplify. My minus must give to the 9x square. My minus must give to the 12xy. My minus must give to the 4y squared. Then I simplify. 7x square minus 12xy minus y square minus another 4y square altogether minus 5y square. Okay. Okay, question 9. Okay, we have gone through some fractions with algebra before. And the number one thing I tell you already, numerator or denominator got more than one term. Number one thing, go and add the brackets first. Remind yourself they belong together. The first fraction, x and minus 3 belong together to form the numerator. This fraction on the right, the 3x and the plus 1 belong together to form the numerator. So I must put the bracket first to remind myself they belong together. Then after that, the approach is, this one is solving. Solving, what is the final? Final is they asking, because solving means they asking you what is x ma. So your answer definitely will be x is what? X equals to what? So from here until here, I know that I don't want any fractions. I don't want to have a fraction on the right. I don't want to have a fraction on the left. So if I don't want fraction, if I just look at the left, I have a bracket over a 3. I don't want fraction means I want to multiply 3. If I multiply 3, it will no longer be a fraction. Okay, so I will multiply 3. When I multiply 3, I purposely choose 3 so that my 3 multiply can cancel with this one. Then I will have no fraction. But same, this is an equation. From this line of equation, I want to go to the next line. Left still equals to the right. I want to multiply 3, I must multiply 3 here also. Okay, then with the same idea, if I look at this fraction, I want the 4 to don't have a 4. Means I want to multiply a 4. Okay, so my right hand side, actually I want to multiply 4. So that this 4 can cancel away this 4. But because I want to multiply 4, here I also need to multiply 4. So what will result from it is, my 3 that I purposely choose cancel already, but I still need to multiply a 4 to the first fraction numerator, the numerator of the first fraction. So I will have 4x minus 3 equal, on the right, my 4 cancel away the denominator, I still have the multiply 3. Then I will have 3 multiply the numerator on the right hand side fraction. Okay, so a lot of tuition teacher or maybe your previous teacher will tell you this is what cross multiplication. Okay, it actually cross multiplication is the result. My denominator from the left multiply to the numerator on the right. My denominator from the right, will multiply with the numerator on the left. Okay, but it came about because I multiply it to cancel away the denominator. Can? So as long as you know you want to cancel out the denominator, you will get to this step. You don't need to purposely remember there is a cross multiplication. Then after that, I want all my x to be together. But now my x is trapped inside the brackets. So I want to free it out from the brackets first, then I can put them together. So to free my x from the bracket, I need to do my expansion. 4 multiply a bracket, 4 need to multiply everything inside the bracket. 4 times x, 4x. 4 times negative 3, negative 12. 3 times 3x, 9x. 3 times 1, 3. Then I want to put all my x together. 4x is already on the left, I leave it here. Then my 9x want to go from the right to the left, so become minus 9x on both sides. My 3 is already on the right, don't need to change. Then my minus 12, I want it to come to the right, I need to plus 12 to both sides. Then the minus 12 will disappear from the left and appear on the right. 4x minus 9x, negative 5x. 3 plus 12, 15. Then I want x, I don't want minus 5x. So I have to divide both sides by minus 5. Then I will have 15 over minus 5. Then simplify, negative 3. Okay. Okay, rhombus. Rhombus, I will just quickly tell you the property. Rhombus is like the slanted of a square. All sides the same. Then I push the top a bit, then it will become a rhombus. Okay, so still all four sides are the same. If AB is 12, BC is also 12, CD is also 12, AD is also 12. Okay, then there's one more property that you need to know, that is the intersection, they will always be 90 degrees. Okay, so from there you can find your x is 90 degrees, your y is 12 cm. Okay, important thing, the middle is 90 degrees. Then the diagonals B to the middle is the same as the middle to D. Okay, they may not be the same as the middle of A to the middle and the middle to C, but A to the middle will be the same as middle to C. The diagonals will bisect each other. Can? Okay, that's all. Good luck, everyone.